All right, so I'm going to quickly try to explain what's going on with stereo imaging and unlinked compressors. So I have a blank Kronos preset. I'm going to make some housekeeping adjustments, turn my sustain all the way up so we have a gate style envelope. I'm going to turn the volume of my oscillators down to 50. I'm also actually going to go back to the amp and drop my output to 55. And okay, let me choose these things called double saws. And what these are two sawtooth waveforms stacked on top of each other. And I can turn up the volume of the second sawtooth and adjust the phase of the second sawtooth. So if you want to see what that looks like, let me pop over to the oscilloscope. And I do not have the volume of this oscillator's second saw up. So this is one saw. This is another saw with its stacked oscillator. The phase of actually all three of these is set to 0. So this is like playing 3 sawtooth waveforms at once. And I haven't routed actually to the output for us to be able to see it. So let me go to output 1, and while we're here, we might as well choose, this is effect number 150, our dual compressors. Let me route to my individual outputs so we can see it in the oscilloscope. And just to show you the effect while we're here, this is a compressor for the left channel and a compressor for the right channel with independent controls. Of course, I will be setting the controls all the same because we want to give the same effect as having unlinked channels, but the same with the same envelope settings. So I might as well go to my final adjustments now. There we are, perfect. And let's go back to our synth. And here we are going to jump into our mixer. I'm going to phase invert this second sawtooth. So I'm canceling out the sawtooth that it is paired with. So we are only listening to the second oscillator from oscillator 1. And that oscillator we can offset its phase. So you can see from a value of 0 to 100, we're traveling from 0 degrees to 360 degrees. You can see that we will end at this point. When we go back to 0, there we are, we're at the same point. If you look at it, we are just about to the left of 8 here. If I adjust it, we're at the same spot. So I just wanted to show you what this control is doing. Let's turn up the second saw for oscillator 2 and leave its phase at 50. And actually, this makes me realize something important. Let me show you what happens to the volume of this oscillator as we adjust its phase. I turned down oscillator 2, so we're only listening to oscillator 1. Notice the volume, we are almost at 0. If I adjust the phase of this double saw, you can see that the volume drops as we get to 180 degrees out of phase, and we lose 6 dB. And if we keep going, we gain that volume back, we gain 6 dB. So I'm going to set this at 50, which is the minimum amount of volume that I could have. They're both at 50. But then I'm going to modulate the phase of each of these with an LFO. I'm going to use 2 different LFOs for this. I'm going to set them to a value of 25. And the reason I'm setting them to 25 is because I'm going to make each of these LFOs unipolar. By pushing this offset up, I move the entire LFO up past to where its bottom portion is resting at 0. And so I've effectively doubled the range of this pole. I'll take key sync off. That doesn't really matter. In fact, let me just go and change this whole instrument to monophonic. I'm going to slow down the, whoops, no, keep that up. I'm going to slow down the frequency to this value of 18. I don't remember what a value of 18 is. I could look it up if you like, but it's just a slow value. That's all that matters if you are going to build this yourself. So we have 2 LFOs modulating each saw, but I also want to actually offset the phase of one of these LFOs, and I want to pan each of these oscillators. I want one pair going out of the left channel and one pair going out of the right channel. So I just gave myself parallel filters, but I bypassed them, but they are each routed to a different speaker. So when I jump back to the oscillators, I can then route my second oscillator to the right speaker. And if you want to see, let me also take off phase inversion. By just listening to oscillator 1, we're coming out of the left channel here with our modulation. And if we just listen to oscillator 2, coming out of the right channel with our modulation. And if we listen to both of them, you can see how these modulations are working in different directions. And in fact, I just realized that our effect... No. Oh yeah, that's right. Okay. Yeah, our modulations are going in different directions. So that means when one is at max amplitude, the other is at minimum amplitude. When one's at minimum amplitude, the other is at maximum amplitude. As you can imagine, that gives a kind of a panning effect. You see what it looks like, and you can listen to it. Left channel, right channel, left channel, right channel. So everything is all set up correctly, and I just want to remind you that each of these sawtooth waveforms there's one sawtooth from each of these oscillators that are phase locked, and then there's each of them have a sawtooth that are being modulated. Their phases are being modulated in opposite directions. I guess you could think of it like that. So in other words, I have mono information paired with stereo information. And that point is key here, because that's what really gives us the effect of dimension. Now that we have everything set up, I can go and we can look at our compressor. So look at the effects through the vector scope. We have this panning effect. See the volume changes. Now, when we turn on our compressor, we are going to be treating each of the left and right channels individually, and we are going to stop the dynamic changes that are happening. But by doing so, we are going to be shifting the stereo image. And that's because we have information that's the same out of each speaker, but because we are evening out the volume, we're kind of like panning it again. Now I have an analogy that I'll go into that will help explain this process really well, but just look for now at the difference of what occurs in the vector scope by turning on and processing these channels in parallel. So it's not really a panning effect, is it? But it is. It sounds like one. Right channel, left channel, right channel, left channel. So this is important. I use this specific example because this is probably like the best case scenario, but you could run into this kind of environment if you're using, and Alchemy brought this up, if you're using chorus effects, for instance, you're going to get lots of phase interactions. You're going to get lots of volume discrepancies between the left and right channel, which manifests as stereo information. But of course, your mix is going to have mono information, like your kick or your vocal. And those things will get shifted in an interesting way when as the volumes are being ridden and adjusted. You get this kind of wiggle movement that's occurring, and this doesn't add any sort of width. But I have this analogy here to help explain what's happening. So here we have a two-dimensional picture. I can. Well, first of all, we have a sense of positioning. I can move this thing left and right. We could say we have a sense of volume. I could like lower its volume. I could turn it up. And we have a sense of width. If we look at how wide it is, it will never be wider than this amount. We can consider this the stereo image of this image. And so if I move it left and right, it's still not going to be wider than this. If I lower its volume, I do change its width. But assuming that we are at a ceiling here at this volume, then it will always be this wide. Of course, this isn't exactly analogous to sound. It's funny because this almost fits with what Alchemy was talking about with volume equaling more sense of width. which I think with, louder volumes, you might be able to notice, different details in the picture as this picture gives, the illusion of depth. But otherwise, we're not actually changing the depth of this image. But by if we had a way to adjust volume and pan position at the same time, we would end up creating the effect of rotating around a vertical axis. This is like yaw on a plane, if you think of it like that. And that's the difference between what's going on when using the compressors and not using them. So by not using them, we're getting a kind of like a shift left and right. But by using them, it's almost as if we are moving the position and volume of each side independently while also retaining the picture. And so what that would look like is this. We are moving the image around what appears to be a new dimension. We've added a new dimension. We can see with our arrows, the arrows never get wider. The arrows are being pulled to center. As I had said before, they will always be pulled to center. They will never be wider than they are. But now the whole thing, this whole two-dimensional image, seems to exist in a higher plane, which is kind of interesting. We almost get like a new perspective on the sound. So that's why it can give the impression of depth as it was described. I think dimension is probably a better wording for it. But yeah, that's what's happening scientifically, and it's difficult to explain these concepts. Quantum, you had appealed to authority figures, which I never suggest. I'm never going to ever take the word of an expert. I will only believe something when I can see it in numbers and understand it empirically. But this should really explain away everything that we're talking about. So before, when I was really just concerned with things being pulled to center, I didn't actually realize that things could be kind of adjusted almost independently. And it's weird to think of volume and stereo position as being separate things, because they are very much the same. A difference in volume between the left and right channel is pan position. But it's the fact that it's a stereo image that's being adjusted in tandem makes these we're shifting the stereo image, which is what gives us this new dimension. So that's the best I can explain it, and I hope you enjoyed that. All right.